For over a century, corporate management has viewed organizations as predictable, Newtonian machines. You isolate a discrete part, you optimize it in a vacuum, and the entire engine is supposed to run faster. But in an era of distributed computing and frictionless global scaling, this reductionist methodology consistently fails. Attempting to isolate variables in a system that is constantly moving leads to a loss of control. To manage modern growth, we have to recognize that an organization is actually a complex adaptive system. A system like this doesn't just execute a set of commands. It absorbs information from its environment, creates its own stories of knowledge, and evolves through nonlinear interactions between its parts. When we try to tune a fluid, adaptive ecosystem using the tools of a predictable machine, we create the structural friction that leads to modern strategic collapse. To intervene effectively, a strategist has to deconstruct the system into three architectural layers. First are the parts, the observable nodes like employees or microservices. Second are the connections, the flow of information and energy linking those parts. And third are the patterns, the emergent macro behaviors like culture or technical debt, produced by those connections over time. We can track the physics of these layers through stocks and flows. A stock is an accumulation, like your total user base or accumulated technical debt. Flows are the rates of change, the user acquisition velocity or the rate of code deployment, that manipulate those stocks. Feedback loops act as the invisible valves for these flows, regulating the mass of the system. But systems have a dangerous vulnerability, structural tension caused by delayed feedback loops. When a delay is introduced, the people inside the system become blind to the ultimate consequences of their actions. This cognitive trap is known as delay discounting. We see it clearly in the biological model of cigarette smoking. The immediate feedback loop of smoking is highly reinforcing, a dopamine response that hits the brain in seconds. But the balancing feedback loop, the systemic damage of pulmonary disease, is delayed by decades. That immediate positive reinforcement completely masks the underlying structural decay. In software engineering, this manifests as technical debt. Bypassing architectural standards to ship a feature quickly provides an immediate reward, a hit quarterly target. But the negative feedback, a brittle codebase that eventually halts development, is delayed. Because the pain isn't immediate, the system actively incentivizes prioritizing short-term velocity over long-term survival. Most strategic failures happen because leaders apply the right solution to the wrong environment. By using the Sinefin framework, we can categorize any situation into one of four domains. The clear domain is stable and linear. Cause and effect are direct and repeatable. Here, the goal is strict adherence to best practices and standard operating procedures. The rock band Van Halen used this domain to build a sophisticated diagnostic tool. Buried in their 1980s tour contracts was a clause demanding a bowl of M&Ms backstage, with all the brown ones removed. To the band, the M&Ms were a proxy for technical safety. Their stage setup involved massive quantities of pyrotechnics and complex electrical grounding, a clear system where one missed specification could be lethal. If David Lee Roth saw a brown M&M, he knew the promoters hadn't read the manual, prompting a mandatory audit of the entire arena before the band would perform. But the complex quadrant is different. It is adaptive and fluid. In this domain, human nodes react to and change their behavior based on your intervention, which makes rigid, top-down master plans fail by design. Then there is the chaotic quadrant, where cause and effect are completely broken in real time. During the 1982 Tylenol cyanide crisis, Johnson & Johnson couldn't wait for data. They had to act first, executing a nationwide recall to establish a containment perimeter before they could even begin to sense the cause. A strategist must correctly identify which of these quadrants they are standing in before they commit capital or draft a single policy. When we misclassify a system, we often rely on proxy metrics to measure success. This triggers Goodhart's law. When a measure becomes a target, it ceases to be a good measure. Consider the Cobra Effect from British colonial India. To reduce the population of venomous snakes, the government offered a financial bounty for every dead cobra presented to authorities. Initially, the wild population dropped. The proxy metric was working. But citizens soon recognized the economic inefficiency of hunting wild snakes. They began breeding cobras in captivity solely to harvest the bounties. The system was now actively incentivizing the production of the exact hazard it was trying to eliminate. When the government finally canceled the bounty, breeders released their worthless snakes into the wild. The cobra population ended up significantly higher than it was before the intervention began. This loop is mirrored in tech companies today. If a CEO mandates a reduction in support response times and ties bonuses to time to ticket closure, the engineering team will deploy bots that forcefully end customer chats to hit the number. The dashboard turns green, but the actual customer problem remains. Because human nodes are adaptive optimization engines, relying on isolated proxy metrics ensures they will be weaponized to destroy the global goal. To navigate these fluid systems without triggering a disaster, we use the D.A.R.T heuristic: deconstruct, analyze, recognize, and test. The test phase requires a critical distinction between an MVP, a minimum viable product, and an MVE, a minimum viable experiment. Launching an MVP often leads to design fixation. Because it requires functional code and a launch, teams fall in love with what they've built and begin ignoring data that contradicts their assumptions. An MVE, by contrast, is a codeless, disposable probe. It is designed to test a single, high-risk assumption without a major capital commitment. If the experiment fails, the failure is isolated and easily dampened without risking the stability of the entire organization. Success depends on where you apply these tests, following Donella Meadows' hierarchy of leverage points. Most managers focus on low-leverage interventions, tweaking budgets or adjusting payouts. High-leverage interventions are different. They target the structural rules of the system and the information flows that govern how nodes interact. Master strategists don't waste time endlessly adjusting localized parameters. They use safe-to-fail experiments to identify and shift the deep paradigms that dictate how the entire system behaves. The hardest system to redesign is the internal narrative of the strategist. Operating inside an organization inherently blinds you to its absolute true nature, a dynamic rooted in Einstein's principles of relativity. Imagine the train platform illusion. To a passenger inside a speeding train, the environment feels stationary. If they bounce a ball, it moves exactly as it would in a stationary room. But to an observer on the platform, that passenger is moving at high velocity. The same law applies to organizations. An internal node trapped inside a fast-moving company cannot objectively observe its own vector or the validity of its own narrative. The daily momentum feels like truth. To escape this, an architect must implement decoupling mechanisms, bringing in external mentors, prioritizing hard telemetry over internal stories, and mapping long-term historical deltas to identify the slow drift that escapes daily observation. Decoupling from internal bias allows a strategist to dismantle traditional market constraints. We can see this in how Tim Cook transformed Apple's operational architecture. There is a classic business trade-off between luxury and scale. You can be Ferrari, high margin, luxury, and scarce, or you can be Toyota, operating at massive global volume with lower margins. Apple bypassed this constraint by exerting absolute control over the manufacturing system. They used their capital to buy the world's supply of advanced manufacturing equipment and placed it inside their suppliers' factories, locking competitors out. By optimizing the structural flow of materials, Apple achieved the ability to produce luxury, premium hardware at a global scale, while maintaining profit margins that are usually reserved for scarce goods. Competitive dominance today isn't achieved by optimizing isolated variables. It is achieved by architecting resilient systems that can absorb complexity, adapt to nonlinear feedback, and systematically dismantle the fundamental constraints of the market.